Calculate the exact bounded area between the curves given by y equals 0.75x and x equals 3.5 minus y squared. Show the exact setup and then evaluate with the calculator and round to the 10th place value. In the previous examples, when we determined bounded area, the area was always bounded above by one function and below by the other function. That's not the case here if we analyze the graphs of the given curves. Working our way from left to right, at first, the area is bounded above by the linear equation and below by the equation x equals 3.5 minus y squared until we reach this point of intersection here on the right, where notice this right bounded area, which is bounded below and above by the same curve, which would make it much more difficult to integrate with respect to x. However, if we analyze the graph from left to right, notice the bounded area is always bounded to the right by the curve and to the left by the line. And therefore, it will be much easier to integrate with respect to y. However, this means the integrand function must be the right function minus the left function, and the functions must be functions of y. Let's begin by writing both functions as functions of y. Let's begin with y equals 0.75x is equivalent to 3/4 x. To write this as a function of y, we need to solve for x by multiplying both sides by the reciprocal of 3/4, which is 4/3. Multiplying both sides by 4/3, we have 4/3 y equals x. And now we do have this expressed as a function of y. This is the line, which is on the left. Let's go ahead and call this function g of y. We now know that g of y is equal to 4/3 y. The second curve is x equals 3.5 minus y squared, or 7/2 minus y squared. This is already solved for x, and because this is the curve on the right, let's go ahead and call this f of y. So we know that f of y is equal to 7/2 minus y squared. And now because we're integrating with respect to y, we now need to determine the y-coordinates of the points of intersection. To do this, we set f of y and g of y equal to each other and solve for y, which gives us the equation 4/3 y equals 7/2 minus y squared. Let's first clear the fractions from the equation by multiplying both sides of the equation by the least common denominator of 6. On the left side of the equation, 6 times 4/3 y is equal to 8y. Equals on the right, 7/2 times 6 is equal to 21, minus y squared times 6 is 6y squared. Because we have a quadratic equation, let's set the right side equal to 0 by adding 6y squared to both sides and subtracting 21, which gives us 6y squared plus 8y minus 21 equals 0. Unfortunately, this is not factorable. We'll have to use the quadratic formula to solve for y, where we have a equals 6, b equals 8, and c equals negative 21. This gives us y equals negative b is negative 8 plus or minus the square root of the quantity b squared minus 4ac, which is the square of 8 minus 4 times 6 times negative 21, all divided by 2 times a, which is 2 times 6. Simplifying, we have negative 8 plus or minus the square root of 568, all divided by 12. And 568 is equal to 4 times 142. The square root of 4 is equal to 2, which gives us y equals negative 8 plus or minus 2 square root 142, all divided by 12. To simplify, let's break this up into two parts. We have negative 8 divided by 12 plus or minus 2 square root 142 divided by 12. Simplifying, we have negative 2/3 plus or minus square root 142 divided by 6. We now know the y values of the points of intersection. For the intersection point at the bottom, the y value is negative 2/3 minus square root 142 divided by 6. And for the y-coordinate of the intersection point at the top, we have negative 2/3 plus square root 142 divided by 6. And now we have all the information we need to set up the integral that will give us the bounded area. The bounded area equals the def integral from negative 2/3 minus square root 142 divided by 6 to negative 2/3 plus square root 142 divided by 6, where the integrand function, again, is the right function minus the left function, or f of y minus g of y, which gives us 7/2 minus y squared minus 4/3 y dy. Let's go and simplify the integrand function, and then we'll evaluate the integral using the Desmos graphing calculator. Writing the terms in descending order, we have negative y squared minus 4/3 y plus 7/2. And now we'll evaluate this and round to the 10th place value. Using Desmos, we can click on the keypad, click Functions, scroll down to Calculus, click on the integral symbol, and now we enter in the lower limit of integration, which is negative 2 divided by 3, right arrow, minus square root 142, right arrow, divided by 6, right arrow, and the upper limit is negative 2/3 plus square root 142 divided by 6. Right arrow, and then in parentheses, the integrand function is negative y squared minus 4/3 y, 4 divided by 3, right arrow y, plus 7/2. Right arrow, close parenthesis, and now we need to enter dy. Let's go ahead and close the keypad, and we can see to the 10th place value, we have approximately 10.4. We round down because we have a 4 in the 100th place value. So the approximate bounded area is 10.4 square units. I hope you found this helpful.